Why is
It's
that?
going to rotate for counterclockwise.
Okay, but there's two vectors, right? Remember we learned that. Paul, you want to look at this one? Forget about this for now. Look at this.
Complete control, you can't.
I know.
Careful.
If you have a circle, right? If you have a circle.
It's a nice circle.
No, you like that, right? If you have a circle, and this is the center of the circle, where is the components of the velocity at any point? So if you're looking at a point here, then you know there's a component that does this.
Right.
There's a component that does this, right?
Right.
So we're looking at this bar at a given point, and we're making the assumption that this bar can rotate about a point A, right? This guy,
Even though it can't.
the tangent, what?
We're making the assumption that it can rotate about A, even though it can't.
Even though it
All the
can,
way.
even though it can.
Well, it kind of does.
In this case, but we're gonna make this assumption, right? We're gonna just forget about the other stuff and just think that this can rotate about that point. And if you look at it vectorly, then basically you have two vectors, right? And always the tangential part of the velocity is going to be the relative, the absolute velocity. And the centripetal part is going to be the relative. Okay? So basically omega, which is angular velocity, is going to be relative, and v, which is linear velocity, is going to be your tangential. Good? So now looking at this, we just drew, what's the relative velocity, the absolute velocity of v with respect to a? Where is it pointing? That's my question.
Straight to the right.
Straight to the right. Did you
Perpendicular
see
to
that?
AB.
The bar, AB. Consider this A to the center, this point to be B. Right?
Okay.
So if you look at like a circle of radius A, then at this point it has these two vectors where the absolute velocity is to the right and the relative velocity is pointing along this guy. Right? So we have this first vector. It's going to be B, B. Alright? Alright. Then we're given another absolute velocity, which is this guy here. This is VC. He's equal to 26 inches per second. Directed in this way. Huh?
Well, that's the velocity at that point.
That's the velocity for what VC. Remember, it's two different things. It's absolute velocity and relative velocity. Relative means, as you know what we explained, let's say right now I do one of these. Right? And let's say this whole chair, it's like a whole fucking platform, right? No, I will do it better. Let's say I'm on a treadmill right now, right? And I'm going, fucking crank it up fucking 10 miles per hour. I'm fucking huffing and puffing. Wah, 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 wah. My velocity is 10 miles per hour. What's my velocity with respect to this guy? 0. Not moving. Maybe it could be 1.2. Maybe I'm moving a little bit, you know? But with respect to this guy, I'm not doing shit. So that's what they ask. With respect to this guy, you're going 26 miles per hour. But maybe the velocity that happens here, what you can see here with respect to this guy, is different stuff. Right? We're good? Good. So now we have this vector here. This vector here tells me that it's going a linear velocity. Now what's the fucking question? They want BB. Right? So they want, what's this guy? And what's the formula for tangential velocity? Tangential velocity. From the other
That question we had in the last quiz, right?
I know that this is equal to R.
Or
Omega.
alpha.
Omega R equals V, right? So we need omega R. So we have the radius, but we need omega.
Radius is 10.
The radius is 15. We need omega. What can I get omega? Well, omega, I have to get the relative velocity of who? I have to transfer this velocity to this one. As relative, so I have to calculate what is this velocity relative to this one. And then once I have what is at this point, then I can calculate, I will have omega. So how do we do that? He said, so now you have some type of velocity here, right? So let's first calculate what's B relative to C, right? So, what's the formula? I forget.